Hi everyone! I was playing a game of Mario the other day and I noticed that there was a bit of a lag between the LCD TV and console. I was rather annoyed by it. Like all other parts were fine, but the display was so laggy that I ended up losing the game. But luckily, I had a trick up my sleeve. So I went upstairs to my storeroom and found my old television. It was this really old boxy TV. And I started to dust it off and then I plugged it into the controller. Then I ended up winning the next game. And this time the television had no lag. You guys might think I'm crazy because an old TV had less lag than a new one. That's not possible, right? It is, and I will explain it to you how. But before that, I will let Prashant tell you about the technology behind one of those old televisions and why it matters.
Hello guys, welcome to Eklavya classes. In today's episode, we are going to be learning how there are real-life examples for English idioms in science. We'll be starting off with the following idiom: one man's trash can become another man's treasure. We'll be seeing this, and we will also be learning the connection between this and the famous cathode ray tube experiment, which resulted in the scientist Sir J.J. Thomson discovering the first subatomic particle, the electron. Now, I had mentioned one man's trash becoming another man's treasure, right? Let's start off with one man's trash. We are talking about the scientist William Crookes here when we are talking about one man's trash. So, what was William Crookes' trash? Let's first talk about what is William Crookes' greatest discovery. William Crookes is credited with the discovery of the cathode ray tube. So, what is this cathode ray tube? The cathode ray tube is something which all of you are somewhat familiar with already, though you don't understand it clearly. Let me explain. I'm sure almost all of you are familiar with how our older TVs and our older computer monitors used to be these bulky, fat, heavy things, right? That is something which is called the cathode ray tube monitor or the cathode ray tube television. So effectively, those are devices which actually came with the cathode ray tube over there. Let's dive a little bit deeper and find out what is this cathode ray tube. Now, let's start off with learning a little bit more about what is this cathode ray tube, which was of course designed by William Crookes. So, this is the setup of the cathode ray tube. Let's talk about each of the parts over here. This entire structure is actually something which is made of glass. So effectively, it's a sealed glass tube. So you can think of it as a glass tube which is sealed on both endings. And what are we going to be doing? This tube is then connected to a vacuum pump, wherein we can effectively suck out the air present inside this particular glass tube over here. What are these two ends over here? This is going to be an electrode. This is also going to be an electrode in this particular case here. So when we're talking about electrodes, of course, we need to talk about the charges on these electrodes. We of course have a nice big battery attached over here. This battery is generally something where we will have a voltage, not 10 to 15, 10 to 15,000 volts is the general voltage we are going to be having across this battery over here. It's a very, very heavy duty high voltage battery. So this is not something which you can do normally easily. It is something which is a little dangerous. That is why your cathode ray tube televisions were all nice and boxy, because the cathode ray tube inside was completely sealed. It was covered so that you would not get shocked. Now, so this battery is going to be something where the voltage is around 10 to 15,000 volts. Okay, alright. The K indicates 1000. Alright, now let's talk about the other parts over here. As you can see, I have put a particular coloring, or I have shaded the corner on that side there. Why have I shaded it? What is the significance of the shading? This shading indicates that this is going to be something which has a coating of a substance called zinc sulfide, wherein the formula for that substance, of course, is going to be ZnS. So that end of the glass tube is coated with zinc sulfide. This is the setup of the cathode ray tube experiment. Now let's put a switch over here. Let's add a switch here. So if I have a switch here, what happens when I turn on the switch? When I turn this switch on, what happens is very simple. We end up seeing something, let's just call it something for now, moving from this end to the other end of the glass tube. This something which was observed by William Crookes was called or was named cathode rays. Why were they named cathode rays? Well, we'll find out, of course. And what are these cathode rays? We will, of course, learn more about them during the course of the coming episodes. So this cathode ray was discovered by William Crookes, but William Crookes was not really interested in these cathode rays. So what did William Crookes do? He basically decided, yeah, I've discovered cathode rays. He didn't care about them. He moved on. We will be learning more about how Sir J.J. Thomson got fascinated by this experiment, wherein something new called cathode rays was discovered, and how Sir J.J. Thomson studied these cathode rays in detail, and how his work on the cathode rays, which were discovered by William Crookes, is what made him famous. And it, of course, led to the discovery of the first subatomic particle, the electron. And simultaneously, it also led to the downfall of one of the oldest and longest assumed to be true theories of the atom, the Dalton's atomic theory, which was assumed to be true for nearly 80-90 years, till Sir J.J. Thomson's discovery of the electron, which was the first subatomic particle discovered, which cleanly proved that atoms are further divisible. Atoms are not the smallest indivisible component, it is still further divisible. Now, I had mentioned earlier that this side is given a coating of a substance called zinc sulfide. Why do we have this coating? First of all, the idea here is this. These cathode rays are particles. When these particles are going and hitting this end of the glass tube here, normally we will not be able to see anything. But if that particular surface is coated with this zinc sulfide, what happens is something very interesting. You will have a small spark of light seen over there. That is, for instance, I'm sure you guys have seen your old fat TVs and your fat TV monitors, or old fat analog monitors, computer monitors I'm talking about. You will see that there are these pixels, correct? What is a pixel? In that television, a pixel was nothing but a small burst of light which was seen. That is effectively what I'm talking about over here. When any particle goes and strikes this zinc sulfide coating here on this side, you will be able to see a small burst of light popping out over there. That burst of light is referred to as fluorescence. Let's start discussing what Thomson wanted to do with these cathode rays. As I mentioned earlier, William Crookes discovered cathode rays when he made his cathode ray tube. This particular experiment was then abandoned by William Crookes. It was then taken up by Sir J.J. Thomson nearly 20-25 years after William Crookes. Now, what did Sir J.J. Thomson want to do? Sir J.J. Thomson was extremely fascinated by these cathode rays. He wanted to study these cathode rays in much greater detail. Now, when I say he wanted to study these cathode rays, what do I mean by that? First, he wanted to find out whether these cathode rays were actually traveling in straight lines. Next, he wanted to find out was whether these cathode rays were actually charged particles. Coming to particles, the next thing he wanted to find out was whether these cathode rays were like light. When I say they are like light, what do I mean by that? He wanted to know whether they had no mass like a beam of light, or if they had mass. This is another point which he wanted to find out. Another thing he wanted to study about these cathode rays was, if they had mass, how heavy? That is something he wanted to know as well. Another point he wanted to find out was, yes, there are cathode rays, but where are they coming from? Are they from the gas, or are they from the cathode? This is a question which was also puzzling Sir J.J. Thomson here. Another question he wanted to find out answers to. This was actually the most important question which Sir J.J. Thomson was looking at. This was effectively, are they the same? What do I mean by are they the same? See, William Crookes had discovered that something was moving from the cathode to anode, so he called it as cathode rays. Perfectly fine, but he never studied them in any detail. He never answered these questions. And most importantly, the last question of Sir J.J. Thomson, whether these cathode rays are the same or are they different substances when we are changing different gases, different cathodes, etc. These were the points which Sir J.J. Thomson wanted answered, or rather these were the questions he wanted answered. So what did Sir J.J. Thomson do? Like every self-respecting scientist, Sir J.J. Thomson did the obvious thing. He experimented on these cathode rays. What we are going to be seeing next are the experiments which Sir J.J. Thomson performed to answer these questions which he had about these cathode rays. Now, at the beginning of the episode, I told you we will be seeing how one man's trash ends up becoming another man's treasure, and how it is connected with the cathode ray tube experiment. I hope you guys have understood by now that the entire cathode ray tube experiment, which was William Crookes' trash, effectively became the treasure for Sir J.J. Thomson, which even won him his Nobel Prize. I hope you guys understand how what has been trashed by somebody else might become treasure for somebody else as well, provided you put in the work and you use the scientific approach and experiment properly like Sir J.J. Thomson did. I hope you guys have understood the cathode ray tube experiment properly. I'll see you guys in later episodes. Thank you very much, guys. Bye-bye.
Now for the answer. Why was the game less laggy when I hooked it up with an old television? The old television used a cathode ray tube display, which are emitted electrons manipulated to display images on a phosphorescent screen. In a cathode ray tube display, this is done with an analog connection, as opposed to LED or LCD displays which use digital connections. The analog connection in a CRT display is extremely useful in reducing input lag within the game. In contrast, LCD and LED displays also have a higher input lag due to the time taken to process the liquid crystals or the pixels to display the correct image. So that's all for today, guys, and see you in the next class.